I think I will start by introducing myself. My name is Johannes Einarsson, and I'm an acoustic engineer here with Treble Technologies here in Reykjavik, Iceland. I studied acoustics at the Danish Technical University and was working in the Danish sound industry for 10 years before joining Treble and moving back home to Iceland. And here with me is my colleague Guillaume, who's moderating the chats and supporting me. And I think I will just get going. And as I mentioned, ask ahead if you have any questions in our Q&A. So I will now fire up the tool. I hope you are all familiar with it. So this is our Treble web application. Yes, always the quick share. Yes, there we go. Just making sure I will share audio if I play something, but yeah, so this is the home screen. I hope you are familiar with that, where you have your project and spaces and then your recent simulations. I have been playing around a bit for this. So I think just deep dive into it. I will open up the tool, jump into a model, and then start with our material builder. So most acoustic consultants and engineers are familiar with octaband absorptions, and I would say most material today with sales guide and what comes from manufacturers is mostly absorption coefficients. But here at Treble, we do wave-based simulations, so we need to have more and accurate descriptions of the materials. So kind of behind the scenes, when we are solving the wave equation in our solver, we need to have a continuous differentiable function that describes the boundary condition and how it interacts with the wave and how it reflects the wave in terms of amplitude and phase. And when you have the absorption coefficient, it only describes kind of the amplitude of the whole system. So what we have to do is that we have to fit a continuous function to that material. So before this fall release, we have only had the input of absorption coefficients. And I'll just do a quick fit just to show, if you're not familiar with the tool, just do a quick fit of a material. So just to show you something that looks like it. And so then we have our own material fitter that fits a complex material in terms of boundary conditions. So you can see that I had a fit here, and because we are fitting something, you don't always get a perfect match between what you input in terms of absorption coefficients and what our model fits to it. So here we have a small difference, but I would say this is acceptable for this material. So then this would be just to have a random material, but let's kind of, I hope you're familiar with this. I just want to quick start with this. So now into the new feature, I will switch to reflection coefficient. So we have input reflection coefficient and surface impedance. And those two are very highly linked, and they kind of describe the complex behavior of the boundary. And this is hopefully coming more common in the material and manufacturer world, where manufacturers are starting to provide surface impedance measure with an impedance gun, for instance, or reflection coefficients. And that kind of enables us to do a better and a more accurate simulation of that material. And as you saw here with the full octave absorption coefficient, we fitted the reflection coefficient, but now we can actually input reflection coefficient straight into the tool. And here you can either directly do it with a file, a CSV, or a text file, or you can just copy it straight into here, which I'm going to do. And that kind of shows the format of it. So it has to be a matrix with frequency, the real part and the complex part, or the imaginary part. So I have here example material that I will input. So just press enter. And now you can see that I have put in the target curve of the material that I want to fit and input into material. So now in the background, we will fit a continuous function to this reflection coefficient. And you can see we have a very good fit, but that is not always the case. So if you have a non-continuous function, something with non-linearities into it, so it can be sometimes hard to get a good match if the input data is not great. So for instance, if you have a measurement for a limited band frequency, then you have to kind of make up the data outside to get the full input from 50 Hertz to 10,000 Hertz. And now you have a more reliable input of a material if you have the measured the reflection coefficient or surface impedance. I will just name this webinar material. Then it's good to put in a category. I would say that this is a porous material, and this is it's always good to have some description for internal use. It's always good to have a default scattering, and then also one of my favorite functions actually is that you can share it within the organization. So if you are an organization or a team of acoustic consultants who are using the material for a specific manufacturer, then one of you can input them all, and then they are available for the rest of the team. A really nice feature. So, but you don't always have a measure impedance or reflection coefficients. So, but do you know the material that will be used in the building in terms of what type of porous material it is, and then the thickness? So we have set up here, which is in beta version now, what we call our porous material builder. And this allows you to calculate if you have a porous material and either on the surface or with air cavity behind it. And then you are able to calculate using empirical formulas what the surface impedance will be, and then you also get from the surface impedance the absorption coefficient. If I'm going too fast over things, then I will just open it quickly. Then we do have a nice documentation. I really like going into the technical reference and material input. And here it goes in more details into reflection coefficients, surface impedance, and then kind of what we do behind the scene, the conversion of absorption coefficients, where we have this fitting problem with possible infinite amounts of solutions to fitting absorption coefficients to reflection coefficients or surface impedance. So you can kind of, if you want to go deeper into the math behind everything, then feel free to go there. Yes. Jumping back into the porous material builder. So here you might want to, for example, you're building a room and then you want to try it with different backing, so with different air cavity or different thickness of porous material. Then you can, from the density and the type of wool, have calculated this. So actually what is being used behind the scene is the flow resistivity, which is used to fit to a model that kind of gives you the surface impedance. But if you don't have the flow resistivity, the measurement of that, then you can, from the density and type of wool, calculate the behavior of the material. So we will just start with 80 millimeter thick rock wool, quite dense, 100 kilograms per cubic meter, and then I will add an air cavity of 100 millimeters behind it, and then you can start fitting widths. And then you can see kind of we calculate from an empirical model the surface impedance, and then from the empirical model we fit a continuous function. So you have the green curve, which is what the material will be in the database when you use it. And this is interesting to see. So, well, I would like to increase the air cavity to 150 millimeters. And then I'll start fitting. And then I get a better absorption in the low frequencies. And then it's always to give it a name and then save it share it with your colleagues. I'm just going to skip that, but I see that Asaf is asking a question. What about other porous materials such as PET or melamine? I think that if I would have to check with my colleagues, but if they can be described by flow resistivity, then you should be able to get a good fit from this. But to be honest, I will talk to my colleagues on this. But I think you should get a decent description of that. But I think, instead of saying something wrong, I think we would love to hear from you. Just send us an email at contact@treble.tech. And then I will give you the right answer. But we have some other experts who are uh, I'm also getting questions on the chat, I see. Is it on the roadmap? Covering board material such as perforated plate as well. Yes, that is on the roadmap to have more kind of build up this porous material builder to have like slitted panels and more complex models in there. That we know that where there are empirical models that describe going from the characteristics of the material over to surface impedance. Yes. I think if you have any further questions, please shoot ahead. Otherwise, I think I will go onto a completely different topic, but I hope you get the gist of how this tool can be useful in your workflow when you're setting up different material or wall configurations and how that will help with your acoustic designs. Yes. And yes, sorry. I would like to move over to a completely different thing. I will want to go over our new reflection tracking module in our results page. I will start with going into a conference hall or a music hall. Here I have let's say a rather typical hall here. And then I have pre-simulated this. So I can jump straight into results and then go into our reflection tracking. So the results in the reflection tracking module is the unique paths from our image source method, which model the specular reflections of the sound. So I will go into just to view something. So you can hear kind of by either clicking here on the left side or kind of with the arrows or your keyboard arrows, you can view all the reflections that are calculated. And as an input to that, here in the advanced setting, you can set the image source order. And then based on that, how many order of reflections you get into this. But here we can see that we have the direct sound. And then if I click left, then you can see here, I have the first early reflection. So this is the from behind the listening point. And you can see here in this view, the SPL behavior of this reflection. And you can kind of, well, of course, the main purpose of this tool is to find the strongest reflections that are having influence on the acoustics of this space. So we can actually go into here, and then we can view the clarity parameters from this design. So here we have just a flat ceiling, and then I can add another, which I have added a reflector into the hall. And then I want to also view 2 and 6, and then we can, from here, see that we have improved clarity significantly, but we can here in reflection tracking actually see why. So we can turn off based on the time scale here, which is different whether if you're designing for speech, if you're designing a studio, or for music, then depending on where you're focusing your reflection energy, where you want to have it to be. And if we just view the hall with the reflector, looking at the first direct sound, and then the group within 2 and 20 milliseconds, we can see that we are getting some extra strong reflections here within the first 20 milliseconds. So that is due to the reflector that is actually increasing the clarity. So you're getting more early signal. So you have more clarity and better speech. But it's actually also interesting to see that if we move over to source 1, and then I think receiver 2, and then if you look at the parameters, yes, this was source 1, receiver 1. Then we can see with the reflector, we are actually getting a burst clarity. And you can see that actually in here, that adding a little bit more here, we can see that when we introduce the reflector, yes, it's more convenient to see it here, then we are actually blocking a very strong reflection from the ceiling due to the location of the tracker of the reflector. And then you can use, and that means that you can use this tool to optimize the placement of this reflector depending on where you want to have the sources and then different listening positions or receivers. And then it's also very good. So this is another feature that we have added along with this, that we have added the impulse response in logarithmic scale. And here it's also very good to see when you start looking at different reflections, then can see where they are in the impulse response. So I'm looking for this spike here. So in the impulse response, then I can see, okay, this is kind of this group of reflections here. And then maybe if you want to minimize this, then you can change your acoustic design. And then you can view it, kind of see where it's coming from. You have azimuth and elevation. And then when I'm scrolling through the reflection here, I can see the order of it, how strong it is compared to the direct sound, time of arrival, and time relative to the direct sound, and then the azimuth and elevation angle. And that is, you can change how the receiver is pointing towards or looking. So if we kind of changing it along the y-axis, then you can get updated azimuth and elevation. I think it'll be best to put it towards the source, and then you kind of know if you're looking towards the source, where is this strong reflection coming from. So hopefully a very useful tool for those who are designing reflectors in spaces like this. But this tool is also useful when detecting flutter echo. So when you're detecting very strong reflection. So I have another use case made by my colleague Oliver, where we open up a fairly big shoebox shape. I think it's 40 meters by 9 by, I think, 4 or 5. And here we have put in a source and a receiver, and then we also have a surface receiver, and all the surfaces have 10% absorption and I'd say a fairly low scattering coefficient. And I would say the sapine is estimated is very high. It's around 2 seconds. It's a great question, Nathaniel Flesher. I am going to look into the flutter echo in this space. So if you just jump into results, we can see that the T30 is fairly high. And then if you go into reflection tracking, we can see that you have strong reflection here in this plane, the horizontal plane, oh, vertical plane. So you have kind of between the source and the receivers bouncing all of the side walls and the floor and the ceiling, and then you have kind of along the long edges also later in time. And you can see here actually from the impulse response view in logarithmic scale that this is actually kind of fairly linear slope decay. So it looks kind of very fused room. And then it's interesting to view actually if we add in comparison where we have update the model and then put in a 90% absorption in the ceiling, but kept the same 10% absorption in the other surfaces. Then it starts become very interesting to see that the logarithmic impulse response, you're starting to get really strong peaks here. So actually what has happened that even though the reflection here are still here, we can see that they are not as strong here in the beginning, and you're kind of getting this flutter echo. So if we kind of go and jump into it, then we can see here linking the reflections to the impulse response in logarithmic scale, often called the reflectogram. We can see kind of that we have a very strong kind of reflections that are not following the linear decay that we saw earlier in the other model. So this will actually be flutter echo. And this is coming kind of due to now that with added absorption in the ceiling that we killed the reflections in that plane. So when there are bouncing from the ceiling and floor, they die very quickly, the sound field, but we still have this 2D sound field that you can see here that kind of it's bouncing between the long edges of the model. So go here and then here, and you can see it kind of where they're coming from. So this is sound bouncing back and from. I think I'm just gonna quickly jump into the oralizer just so we can quickly listen. I have I think a clap would be best. I like this clap single high energy. Let's listen dry. Do you hear it on your side? Great. Okay. And let's jump into the model. So this is the model with a 10% absorption. And we see countersign, it's kind of reverberant, diffused, but I think you can hear some kind of flutter echo, but you kind of just didn't see it in the reflectogram, but and then you can hear kind of the flutter echo. Well, what can we do about it? Well, the best thing is that we detected it in the reflectogram. So I'll just add in both of them. And then we look at kind of the reflections here. So here is the model with the absorbing ceiling. And then here is the diffused with reflections in all directions. Well, what you would do, or how my colleague Olav solved it, is that he changed the scattering on the long edges. Let's see. Well, no, actually, this does not solve it, actually. So he added more scattering on the long edges from 0.3 to 0.9, meaning like if you have some diffusive thing, some like diffusers or more rough materials. Well, actually, we see it still in the reflectogram. So you can kind of hear these strong reflections. And then that means actually this is come from these here. And then, well, actually that means for this design, I would recommend adding some absorption. So if we let's just duplicate this, and then I will add on this. Let's see if 50% absorption and then higher scattering will solve it. We have a question from Sebastian Holm. It's very common to make reflector convex. Will the model work well with rounded shape? And does it take the full dimension of the panel into account when calculating reflection gain? So regarding how it works with rounded shape, we are working on improving our geometrical solver. Without saying too much, we have a really good speed up. So it has had been a little bit slow when you have kind of these curved surfaces, which are kind of broken into smaller pieces, so or smaller triangles. So we have a solution for that, which will be out soon, or I shouldn't say soon, but it will be out hopefully soon. Let's say that. And regarding, so yes, it will work well with rounded shapes. Regarding the second half, does it take the full dimension of the panel into account when calculating reflection gain? This is a really good question. No, I'm going to say no, because these reflections are estimated as kind of specular waves using the ISM method, which kind of where you trace a beam, or not a beam, sorry, a ray, essentially. So I don't expect it to calculate for the whole reflector. It will be from points on that reflector. So, but this is actually a really good input, and I will have a talk with our product manager, Ólafur, if we can accommodate this. Because you could, of course, simulate it as a beam that hits the whole thing, but it's more complicated. But really good question, actually. And just quickly, while we're on that topic, if you have ideas on improvements, then we have here on the left panel, our live chat, we have feature requests. You can, of course, request the bug. And if you need support, then you can speak to a specialist from our live chat. I know that is very valuable when you're working with a new tool and you get stuck. Then you either get support for them, they will point you towards the right documentation, or if you have some difficulties, then we try our best to support our customers and give you the best experience that we can. I now have added the absorption in one end on this Flutter Echo model. Let's see how it behaves. I'll start with the so here you can view you can view the impulse response here, but you can also do the logarithmic impulse response on this plot also. Yes, jumping into the reactogram again. Did my solution solve it? And I will say no. Or did I pick the right one? Adding 50% absorption at the boundary did not fully solve the Flutter Echo. I can still see it here in the IR. But hopefully it will be less. So here we have reflections of around 50 dB. This is around 300 milliseconds actually. They are not improving. So I will go back to the drawing board. Yeah, this reflection only hits this side once. So I'll probably have to do the other side also. So this could be a fun thing to play around to. I really like that you now have a way to detect flutter echoes, and then you can, in the tool, iterate and kind of eliminate them. We have another question from Henry Dran. In the future, will it be possible to add individual elements into an existing scene? For instance, if you want to measure the impact of absorption panel in the room, it would be very convenient to simply place the panel within the current geometry rather than need to upload an entirely new room. So I would say like the current workflow, you have this here model, you would draw it up in SketchUp, upload it to Treble, set up simulation, then you can in SketchUp fetch the model, draw in the panel, upload the model, but you have to make sure that you are within the same project. I think preferably same space. And then you can copy the simulation that you have done previously onto the new model, and then simulate by adding appropriate to that panel, and then viewing the results and then comparing them. That will be the current solution to this. It's a really good question. I would say personally, I would like to have some way of adding elements into the model within the tool. But I can't promise it to you. I will have a chat with our product manager, Oliver. I think the technical difficulty would be for us will be to adding a geometry within this tool. We don't have that functionality, so I don't think this will be coming anytime soon. But I agree, it will be a really nice feature to have. Hopefully make it an even smoother tool to work with. But on the topic of new features and new things, I just updated today a minor new thing. We now have in the results, when you're looking at SPL, now you can get the total SPL. So you can get a zero-weighted SPL, C-weighted SPL, and an A-weighted SPL. So a minor detail that hopefully make your life easier. I do like that. Actually, it's much nicer when you have a surface receiver. Surface receiver here. Yes, I did that here. Yes, sir. There we go. I have this just classroom, and then regarding viewing SPL, it's also really nice to view that in the surface receiver. So SPL, and not only per octoband, but you also have zero-weighted. Should we go to view this source? No, it's number 2, I remember. And then you can view it as an A-weighted also. This one, yes, this is with a harder ceiling. And I really like here, when you're viewing C-weighted, you can see that you have some low frequency energy here. But if you look at the A-weighted, you can see kind of it's more focused on in front of this loudspeaker. Oh, sorry, yes. Comment from Mark DeLong, would be great to add paneling in the drawing like you can do in Katna R. That's a great input. like I'll say this, we are always adding new features, and it's really valuable for us to get feedback from you on what is needing and what can improve our tool. So I'll mention this to our product manager. Great input. Reading more Q&As from Dennis Bush. There's a question about possible use hemispheric or wall-mounted sound sources. So there's a added complexity to that. We are a wave-based tool, so we are I would say kind of can sometimes be limited by that, where we have to have a really good setup. For instance, if you have used wave-based already, you have to have a watertight geometry. But we are also have restriction regarding where we can place sources. And that comes from the initial conditions in the wave solver. So depending on the transition frequency that you choose, and the lower transition frequency, the more space in the model the initial condition is, and then with higher frequency, it's smaller. So I am getting to the point that hopefully in sometime next year, we will be able to relax where you can place sources, hopefully place them closer to walls. Regarding wall-mounted sources, then that would kind of go into a little bit different topic. I think we aim to, in the future, to be able to use geometrical acoustic solver with wall-mounted sources, but we are kind of making sure that it works. Kind of we have to be very thorough when we are adding new features like this, making sure that we are giving valid results. So in some features, we are moving much slower than other features. So especially regarding our core technology. So hopefully in the future, but Dennis Bush, I will take this to Oliver, our product manager. Andrea has also a question. Will it be possible to create surface receivers from offsetting existing surfaces in the model? This is a really nice feature that we have thought about ourselves. Hopefully in the future, yes. I think I know other tools have this, but it can be very convenient to be able to click a floor and just drag it up 1.5 meters to have listening height. So this is something that we have in our backlog. It's in our mind, so we don't have a solution for that, but we aim to in the future to do this, definitely. Yes, to further answer Henry Trent about the plugin, it's only in SketchUp as of now. If you're using other tools and you feel like you would love to have a plugin in there, let us know. The more people that tell us about it, the more likely we are to implement it. I don't want to, like, we have played around with Rhino, but we're not sure if we will do a plugin there or not. And then kind of in terms of feature, we are going to do a big feature announcement in February. So I think just to hype that a little bit up, we are getting some new features in that will kind of improve your geometry workflow, hopefully by tenfold. So follow us and be in the loop when that comes. A couple of Q&As more. Question from Aravind: in geometry solver, can we expect reverberation time only based on Sabin's formula? Like, for instance, calculating RT without inserting speaker and receiver area. This is a really good question. This is actually a super small, super nice feature. So we have Sabine already, actually. So I will just create a duplicate of this model. Let's just delete the sources for fun, and then we delete the receivers. But I have assigned the materials. So I have the bookshelf, I have the tables, the flooring, the ceiling, and then we have Sabine estimates down here under a material filter. So if you're doing multiple rooms and you don't have time to kind of set up a simulation, but are maybe used to doing this in Excel, actually, then you can do this in Treble. So we do have it's a hover window here. So we have Sabine formula based on the surface area and the kind of surface absorption calculated for you. So you don't have to do it in Excel or some other. So once you get your model in there and have assigned materials, then you get this estimation. So hopefully that would be very useful for you, Arvind. And then a question from Rafael. A typical slat panel is made of melamine and wood pieces mounted over a PET support. The materials usually come with only absorption information. Is there a way to have reflections and scattering coefficients in Treble? So we don't have a specific material builder for this case, but I would say the current workflow would be to put in the absorption coefficients for this from the manufacturer, and then let's say it's like this. And then once you fit it, then you have a reflection coefficient based on that absorption, the measured absorption. Regarding scattering is always a complicated topic. I would go into, I do like our best practices when simulating in Treble. And then we have this kind of rule of thumbs when working with scattering here. So that would be my answer to you to get this material into. But I will say that this is something that we are working on, and we are communicating with material manufacturers to get better data into the tool to support you in working and having a better workflow. So I hope this answers your questions, Rafael. Leonie has a question. Will there ever be a line graph for reverberation times? And will it be possible to compare Sabine and the simulated reverberation times in one graph? This is actually a really good question. We should. I think that it will be very beneficial to be able to kind of go into results and then be able to add here, and then you could select the shape bind. So I am not promising it right away, but I will hopefully in the future. I recommend that I will mention this within the team, but I also do recommend that you just add a feature request here. So then we can let you know when we will finally have that feature. I think it'll be a really small but nice feature. But I would say our kind of roadmap, kind of short term, is kind of very fixed, focusing on stuff for February, but the rest of 25 is very open. Question from Asaf: how about creating reports from the results instead of copying images manually? I agree, and I have been talking about this within the team for a long time. I would think it would be really beneficial if you could just add in your comparisons of different designs and then be able to create a PDF with everything. I will mention it to the front-end team and all of it. It's good that you agree with me. I think this would be a really cool feature to have. So yeah, keep them coming. Use the feature request on the tool. We monitor that very. Our eyes are on there, and we hear you, and we like to get feedback from you, and we are always striving to make the tool better. I think that we are running out of time, so I think I will just close the tool here. I want to thank you for taking the time to look at this webinar. It's been great getting your questions and feedback. And I hope you learned something from this. If you also want to see more webinars in the future, and have ideas for topics or something, then feel free to reach out. It's best to contact at treble.tech. That way, and then it goes right through our system, and then we have the system that covers everything, so then we can get the whole image of everything. So I want to thank you guys, and I will say farewell for now. Have a great day. Thank you.